Good morning, everybody. After this wonderful piece of music, we will again focus on science. And it's with great pleasure I introduce to you Dr. Kenny Rose as the opening keynote presenter. Dr. Rose is presently a Franz Marek Professor in Sustainable Ecosystem Restoration at Horn Point Laboratory, University of Maryland, Center of Environmental Science. In his research, Dr. Rose uses mathematical and computer simulation modeling to predict and better understand the dynamics of fish population and food webs in estuaries, lakes, reservoirs, and oceans. Dr. Rose has served on more than 30 national and international advisory committees and editorial boards, and participated with several ICES working groups. His work is truly collaborative. He has published over 175 papers with more than 400 co-authors. Dr. Rose was recently awarded the Award of Excellence for Lifetime Achievements from the American Fisheries Society. Dr. Rose has been involved with a wide range of fisheries and environmental management issues, and has much experience from the sometimes tricky arena where science meets policy and very enthusiastic stakeholders. Today he will share his experiences and thoughts on how to promote science for bringing clarity and equity to complicated environmental situations. In his talk entitled Multidisciplinary Team Science and Engaged Stakeholders, Two Often Neglected Aspects of Coupled Human-Natural Systems. Please welcome Dr. Kenny Rose.
Thanks. Well, I want to thank everyone, particularly the organizers, for inviting me to give this talk. You'll notice on the screen it's a slightly different version. Engaged stakeholders can easily become enraged stakeholders, and that does change the dynamics somewhat. So what I want to discuss with you is actually a very condensed version of a portion of a course I used to teach at Louisiana State University until I recently moved. And I gave a talk on this topic 14 years ago in Quebec City, and I'm happy to report that a lot of progress has been made on this topic. What I'd like to do is go through some of my experiences and then some of my thoughts on not only dealing with stakeholders, but dealing with colleagues and students and postdocs and everything probably but your family that you're on your own for. So there's been a great evidence emphasis on team science, and we hear disciplinary, multidisciplinary, interdisciplinary, and finally transdisciplinary, and I won't try to define these. But there's been a great emphasis on that. The National Academy of Sciences in the United States facilitating interdisciplinary research. Now it's even moved a little bit better, and it's now enhancing the effectiveness of team science. These are some they're somewhat old, but they're still very valid. Number of authors put paper in one side is in science, and then the other side is broken down by number of authors. And you'll notice I need to get involved with that blue bottom line with 1,000 authors. I would say just getting the affiliations correct must be quite a challenge to do that. And I would guess that's in physics. They can do an experiment that lasts about a millisecond, and then they have 1,000 authors on it. So there may be a lesson for ICES in that approach. This was a very good paper that started on the same ideas. Here it was interesting, again, a number of authors up through the last 40 years or so. And you can see economics, ecology, astronomy, rising authors per publication. The top one that actually is the only thing I've ever seen reach steady state, truly steady state, is the number of producers for Broadway shows. So apparently if you put more than 6 in a room, it doesn't work. I thought that was kind of interesting. This was also, again, an excellent paper, almost 10 years ago, by Advocacy. This was, and we just saw, I think Christian put up a network diagram, and this is an example of one as well from Science. Just showing on the left, or to think who's left, your left, Galileo, Newton, Crick and Watson, and then finally the International Human Genome Sequencing Consortium. And it's continued in that trend, by the way. You can now go on the web, of course, and this was, I found from the University of Florida, not far from here. They were doing an analysis of who was working with who within their science departments at their university. So there's been a lot of work on this network type analysis and trying to understand using some output, such as co-authoring papers, et cetera, on who's working with who and who are nodes and who are centers of activity, which is great. The other trend that's been going on is increasing stakeholder both knowledge and involvement. These are just some examples that I've been involved with. The upper right, with myself looking fairly exasperated. Of course, that's the picture they took and put on their website. I was talking to the California State Water Board, and I believe they asked me a question, how much water do fish need? And you get this. You see my hair is, this was after a little while. Those are the simple questions we get asked, and I must say that it's at times very complicated answers, and we have to think about how that appears to non-scientists as well as to our colleagues. There are some other ones here. You can see the Klamath on the left. I'm going to go into that in a little more detail shortly. To me, the entire issue we're facing, we may do excellent science, but it all comes down to trust. And why do we trust each other, and why do complete strangers trust us when we tell them that they're going to have to catch less fish next year? This was from a group, Compass, who does excellent communication work. Trust is your willingness to embrace the advice of a group of strangers, excuse me, because you believe they, A, know the truth, B, will tell you the truth as they know it, and C, have your best interest at heart. All of which depend on who you are, we'll come back to that, who they are, and what you're talking about. In the United States, there's a growing distrust of science, and I'll just add, it predates the recent inauguration of our new president in January. This goes back as a trend almost a decade to a decade and a half. It may be accelerating now, but it's not brand new. This in the United States was a study where public trust in science by political ideology. The important part of this graph is not that one line is trending down and the others are stable. It's the magnitude on the y-axis. They're strange units, but it basically means that there's general distrust of science from everybody. These are some examples of that. National Geographic, the war on science. They have listed their climate change, evolution, the moon landing, vaccinations, artificially modified food. Mr. Rick Perry, who was the governor of Texas, said, "Do not succumb to the notion global warming is man-made." One of our distinct politicians in our federal Congress pitched a snowball on the floor of the Senate last month to show that 2014 was not the warmest year. Now, first, to do that is one thing. I don't really understand the logic of that argument, but it gives you a sense of this distrust. I will admit, as fisheries, as I'm a fisheries person, we haven't helped it completely. Talking about empty oceans by 2048, talking about global overfishing, no super trawlers, not here, not anywhere, These are just some of many examples where we have made statements that may make scientific sense but may not resonate well with others who don't understand the context. I did not know that Christian was getting the award partly for his work in the Baltic. I found this, it says Baltic overfishing, who's to blame? And I think the fourth one down is Christian. If you look down at the lower left, we want our red snapper back. You're almost in that territory now, near the Gulf of Mexico. You're on the other coast of Florida. And you get the idea. The bottom right was a National Academy of Science committee I was on because there was questions about whether NOAA and NOAA Fisheries was successfully rebuilding our fish stocks that were overfished and overfishing. These are just some other examples. No cod, no job. Deep distrust. Science for hire, what industry's deep pockets are doing to our fisheries. Cod report has no scientific value. We're going to get more positive soon, so bear with me. So why is this happening? And there's been many reasons proposed why this distrust has been increasing, it seems. Some have said our scientific process is just not working. For example, peer review has become very challenging to get qualified reviewers to agree to review things. Retractions get a lot of media attention. And even though they're a tiny, tiny percent of published studies, they still get the attention, and the public perceives that as a trend and as a regular thing. Some scientists oversell what they're going to do. Sometimes the media misunderstands and hypes it up. Poor communication, doubting by politicians. One we're going to return to, conflicts of interest and perceived conflicts of interest. Whether we should be advocates or not, whether we have agendas when we're doing our science, stretching authority, ignorance, the 24-hour news cycle, the list goes on. There are many reasons why this is happening. These are just some examples. People, I don't know if you follow the United States, but there's a movement that thinks that vaccines cause autism. The National Academy of Sciences on the lower left, actually the Institute of Medicine, concluded it does not, and that website I got on the left was published several years after that National Academy report. There's a very good book called Merchants of Doubt, and that bottom one, so this is not new, by the way, in the United States, smoking in the tobacco industry predates some of us in our careers. But that's just a flow chart of how misinformation was passed around climate change. Some of these you may not recognize as being relevant, but they are a growing distrust of science. So on the left, why chocolate is good for us, and on the right, chocolate health myth dissolves. Eating egg yolks is as bad as smoking, and then on the right-hand side says, never mind. 10 reasons to stop eating red meat. Hurrah, eating red meat is good for you. Red wine, the unexpected health benefits, and then on the right, red wine don't improve health. And perhaps the most bothersome one was ice cream and bacon are new superfoods, and eating bacon lowers sperm quality, study shows. So the public is confronted with this type of information, and it's very difficult for them. And for me, I'm still not sure if I should eat bacon or not. I'm weighing the positives and negatives to figure out what is truth in amidst all the noise from the web as well. This was a National Academy of Proceedings of the National Academy of Science. The x-axis is competence. This was a major survey of people by professions and what the public thinks of us. And they labeled trust warmth on the y-axis. So what's interesting is that if you look at professor and researcher on the right-hand side, just above accountant, by the way, we are considered competent, and as a profession, we're trusted. So it seems to be it's as scientists we're not trusted, but let's check. This was in USA Today about 2 months ago. People trust science, so why don't they believe it? And that's an interesting way to think about it. If you generally ask people, do you believe in science? Yes. Do you believe in the science that's going to reduce the fishery that you're involved in? Maybe not. So there's this disconnect between those two. Their answer in this USA Today article, so as you can see, I'm reading, the top journals in the field. They blamed it on polarization of our general society, and in the United States we're suffering from that tremendously. General lowered curiosity of the public. Social media, there's no peer review, it turns out, on social media. More partisan press, access to information, and an interesting one, lack of universally accepted experts. I would not have put that on the list. What I found very interesting in this USA Today was a quote, "A human being cannot grasp something as fact if it in any ways undermines their identity." And we're going to come back to that. That turns out to be a very profound, I think, a profound statement. Another person from Yale University, Dan Kahan, "When you encounter facts that do not support your ideas, your belief in that idea actually grows stronger." That is, people get entrenched. Some say we're in an era of post-truth. In this era of post-truth, it means relating or denoting circumstances in which objective facts are less influential in shaping public opinion than appeals to emotion and personal belief, i.e., science and scientists get marginalized. I used to have this slide, and by the way, if I've given versions of this talk before. If you've heard it before, I apologize, but there are some new things coming, and maybe you'll get a little bit more out of it this time as well. I used to have "Who Said These Things," and I took that off recently. So carbon dioxide is natural. It occurs in Earth. It's a part of the regular life cycle on Earth. In fact, life on planet Earth can't even exist without carbon dioxide. That was actually one of our topmost politicians, office holders in the United States. You can't just let nature run wild. That was the governor of Alaska at the time. Facts are stupid things. It isn't, which, by the way, as an aside, is a misquote of Ronald Reagan as president. That's not actually what he said. And I should have corrected it here. Do not succumb to the notion global warming is man-made, and there's no scientific consensus on the human role in climate change. These are just examples. One of the best ones I like, I was involved with a fishery controversy not far from here. And at a coffee break, we had just done a panel review of the stock assessment and said you have to go from 7 million pounds to 0. They called us back in within that year because some of the data turned out to be faulty. We then came up with 3 million pounds. And then 2 years later, there was, for those in fisheries, a new fecundity at age key. We sat there. This was the third meeting in 2 years. And the stock assessment person, who will be nameless, goes, "Oh no." And it was 7 million pounds. And so we had to go out there, and I was elected. I was the one sacrificed to tell them, never mind. And all I could say was that the process worked. There was peer review, there was checks and balances, and the process worked. And at the coffee break, a stakeholder came up to me and said, "I used to think you were a greenie, anti-fishing, and knew what you were doing, and now I realize you're sincerely trying to be objective, and you have no idea what you're doing." And I use this in my class when I teach this, and there's only one answer you can respond to that, only one possible answer. "Thank you for your comment." That's the only thing you can say. So what I want to get to today, with that very quick go through of what I perceive as the current situation, is I want to shift it from the view of network analysis and who's publishing with who, and with that backdrop of distrust of science and growing stakeholder involvement, I want to talk about people as individuals. And relate that to the team science and stakeholder issues, how you act and how you treat others. And we do a lot of the cartoon on the right. I'm confident that with the right mix of role-playing exercises and prescription medication, we'll make a cohesive team. And I urge you that we have really not emphasized this part of our jobs and our roles in society, and we need to. And quite honestly, I know William referred to him as a young scientist. I consider myself mid-career right now. Maybe a stretch towards the other end, but we are not training our students. We're not mentoring the young scientists in how to do what I'm about to tell you I think we should be doing. And that is thinking of as individuals and individual interactions. There's some good news, and certainly in fisheries, that's been recognized. Again, I mentioned I gave this talk a while ago, and it was, you could not find anything. And now in California, there's the Ocean Science Trust, and their motto is building trust in fisheries science. There's the Scientific Roundtable, the role of science in fisheries management. And the first thing is trust is precious and difficult to gain. That trust idea, a paper in marine policy. There's many examples of this. I like the one on the upper right, the Fisheries Transparency Initiative. That's a very interesting way to approach a trust issue. We have the Baltic Sea. I don't know why I keep picking on the Baltic Sea, but this was good. Best practices, I don't know why it's in quotes, but maybe Christian and I can discuss that later. Best practices for fisheries management, and if you go through the document, the word trust occurs 26 times in that document. An investment in trust on the right-hand side, and on the left, a paper about stakeholder participation. So this has been recognized, which is wonderful. That's a little different picture of me on the upper left. Congress requested a group of us to come and explain to them if they're spending all this money on fisheries and ecosystem restoration, why is everyone unhappy? Again, very simple question that deserves an answer. But you try answering that in 7 minutes. It's not so easy. And by the way, our PowerPoint slides, we're not allowed to have words on them, only pictures, which I thought was another interesting thing. So team science, how do you make it more effective and efficient from the point of view of individuals, right? Network analysis is wonderful and all those things showing kind of a 10,000-foot view. But how do we deal with each other? And it's the added value question. It's been around for a long time. Why fund an institute when you can fund 10 little projects, right? Well, how is the total greater than the sum of the parts? There's added costs involved in having team science. And how do you go about doing it? And so the cartoon says, we like to bring together people from radically different fields and wait for the friction to produce heat, light, and magic. Sometimes it takes a while. That is not a good approach, although I will say it's not uncommon recently. So I'm not the only one to be thinking of this. This was trust and confidence at the interfaces of the Life Sciences Society. Two excellent quotes, and I'll just paraphrase the quotes. Public trust in science suggested a complex landscapes in which personal characteristics like culture, religion, values, and personal histories, when combined with science's own shortcomings, can promote a lack of trust in both the scientists and the scientific enterprise. Remember the word ethos. We're going to come back to that. When you talk about trust, you have to know a way a group thinks, how they interact, how they communicate, how they educate. You have to know what their roles and relationships are. What are their values, their practices? What are their expected behaviors? So when we're training students, and many of us are educators in one form or another, there's excellent technical training that we provide students. Modeling courses, these summer schools, that happens to be one I was involved with, which was ICES summer school, wonderful. But we don't seem to be teaching our next generation how to deal with each other. And while it may be optional for our mid-career people, we can work in a small group, we have choices. They have no choice, the next generation. They will be working in fairly large groups and dealing with stakeholders. It's not optional anymore. So how do we do that? Well, one way we do that is the environment we work in. If you look on the left-hand side, that's actually an architectural laboratory design that's trying to design collaborative spaces, which is great. And there's little things you can do, right? Turns out couches are more conducive to discussion than separate chairs. You put out coffee, right? Little things you can do. The right-hand side, if someone is here from Del Terrace, I'm not sure. I visited Del Terrace to give a talk. They really have tried to encapsulate the notion of interactions. And the more times you interact with someone, either passing in the hall or chatting with coffee, a lot gets done. It's a beautiful building, by the way, and I was very impressed with that. There's been some institutional. This is the CCI, the Cambridge Conservation Initiative. It's been designed to provide collaborative facilities to foster innovation, generate solutions to conservation challenges, and create an ideas-rich environment to inspire future generations. And at the time this was proposed to have 500 people co-located there from various institutions and units. It's a wonderful idea. This was one of my favorites. The Laboratory of Molecular Biology has had the most Nobel laureates, at the time at least, of any institution in the world. It's not very large. Remember, Crick was a physicist, Watson a zoologist, and don't forget Brenner. We sometimes forget about Brenner, who was a physician. And Crick and Watson sat back to back in one office during their career. And the urban mythology is, in order for one to get out, this office was so small, the other had to move their chair in. So those who are at places where we've had lengthy discussions at meetings about who gets what space, remember Watson and Crick. That was important. The director was once asked, how do you get so many Nobel laureates out here? And his answer was, no doors, no locked cabinets, and no secrets. And that's an interesting way to view things. There's been progress. This has recently come out, creating and maintaining high-performance collaborative research teams. The importance of diversity and interpersonal skills. They talk about teamwork training. They talk about how we deal with each other. And on the left-hand side, hopefully you can see it, is basically their table of contents. And if you start with preparing yourself for team science, fostering trust, communicating about science, fun and games, maybe topics you might not consider as part of training, but it should be. So, why do we trust each other is basically because we think the other person is acting in an ethical way. But ethics is complicated. It's very complicated. And this is where in my class, I always preface this by saying, do as I say, not as I do, because it's very easy to find examples where I slipped up, didn't realize who I was talking to or something. But you can see on the right-hand side that that's a very, lots of words around ethics, morality, integrity, principles, choice. So why is that so important? Well, what happens when trust is lost? In some ways, it's a missed opportunity, but more importantly, it's confusion and inequity in the solutions. So if you think of fisheries and it becomes distrustful, you're probably not going to get to the optimal solution. You're going to end up compromising, and most often, it's the resource who takes the disproportionate impact of it. And sometimes it leads to contentious situations, and these are ineffective. They carry over to other situations that really had nothing to do with the original. And it's an inefficient use of both economic, human, and natural resources. So it's very important to develop trust and maintain trust. So what can happen? Well, this is an example I was involved with, which I guess is not a good example to give when it illustrates losing trust. The Klamath River had a dam on it, and they wanted to remove it to restore salmon runs. And these are headlines from various newspapers over time. Klamath propaganda, who do you believe? Independent peer review says dam removal science sound and reliable. Klamath River, a big dam controversy finally resolved. Uh-oh. Whistleblower taking his case to the public. Paul Hauser, Bureau of Reclamation's former integrity advisor, says he was fired for voicing concerns that the decision to remove 4 dams is being based on politics and money, not science. He spoke at a Tea Party meeting Sunday in Klamath Falls. William Buffett's dams kill salmon, jobs, and communities. That's my personal favorite. I had to look up why William Buffett got involved. Turns out he has a major interest in the company that owns a company that owns a company that owns the dams. So what happens? Well, the Secretary of Interior issues a report based on the science of whether the dam should be removed. That was very controversial. So I was involved with a review of that, the scientific assessment. People did not like our conclusion. And again, a very simple question: how many salmon will be created if you take the dams out? So there was a peer review of the document done by another group. Whoops. And I believe at this point the dams are still in, but I'm not sure. This is not a good way to go. The idea got lost. In fact, I went out to a public meeting, and my wife is at home, and she turns on CNN, and they're talking about the sheriff's deputies who are in the back of the room at a meeting in Klamath Falls, and she calls me up, and I said, no, nothing. The one thing they know is you never hurt the reviewers, because that's not a good strategy. But it was not a pleasant situation to deal with. But again, a simple question. Many of you perhaps have seen this picture before. That's my daughter, who now is a second-year graduate student at University of Texas at Austin. This was in the old days before PDFs. You really couldn't appreciate how much information you were getting. This was a red snapper stock assessment, and I recently moved from Louisiana to Maryland. I don't miss red snapper issues at all. I'm very happy without them. People ask, aren't you going to miss that and the Deepwater Horizon oil spill? I said, no. This was the background information. This arrived in a huge box at my front door. This was the background information, and every one of those is a document, not a page, for the actual stock assessment before we would arrive in Miami, actually, to do, at the time it was the Reef Fish Stock Assessment Panel. Now they have a CDAR process. But this was the background information to read. And I made my daughter stand there, and she regrets that ever since. That's what happens when trust is lost. So how do you develop trust, and how do you maintain it? This was a very interesting book. If you haven't looked at it, I encourage you to. Overcoming the 5 Dysfunctions of a Team, a Field Guide. And I show it here. It's really for business, but it applies to science as well. The bottom part of that pyramid is absence of trust. That's how it starts. So absence of trust leads to fear of conflict, leads to lack of commitment, leads to avoidance of accountability, leads to inattention to results. So what can you do? So the first thing you can do, and this is very hard to do, is maybe this evening or at the break or something, just think about yourself. How do you think you appear to others? Right? And it's challenging to do that. And I will tell you from experience that if you repeatedly have trouble in groups, I've got bad news. It's probably you. And but you can adjust, you can fix that. It's not always you, but repeatedly it often is. I've had someone come to me and say, I can't believe so-and-so didn't include me as a co-author and this and this and this. And as I gently started navigating through this, it quickly occurred to me that that person didn't deserve to be a co-author, probably from their own description, that person was being difficult, right? So think about that. The other approach, and you need both, is to respect others. And I can only talk from the United States right now. We seem to be at a low point with that. And that carries over into everyday activities and science issues too. So there are three common issues that get us in trouble. Get me in trouble, I should say. But I suspect it's pretty general. And that is authorship and credit, conflicts of interest. By the way, if it's a conflict of interest, it's easy. You get out. It's the perception of a conflict of interest that's the problem, right? And should we be advocates or not? As citizens, we should be advocates. As scientists, I'll talk about old school and how we were told not to take a management decision stand or policy. And it's kind of interesting. So how do you learn about yourself? Well, I don't know how many people are familiar with the Briggs-Meyer personality typology, but it's very commonly used, and it's a series of questions. I use it in my class. Everyone takes it, and then we try to guess who's who based on that, and how would they act in a team. And what people have done, including this group here, is they have mapped, in a discipline called industrial psychology, they have mapped either Briggs-Meyer, there are other typologies as well, to how your strengths and weaknesses in a team. And it's very interesting to look at. And my son, oldest son, who works for NBC News up in New York, part of his interview was almost a 3-hour personality assessment. Now, I know we can't walk into an ICES working group and have everyone take the Briggs-Meyer test. Well, maybe we could, but you learn from that, not what it's 4 letters, by the way, not what typology you are, but you observe people and you get a sense of how they interact in a team. And we all know them, the different types, and you'll see. But they can take a Briggs-Meyer. So by the way, it's 4 binary letters. So this person happens to be ISFJ, and they think that this is what they would bring to a team, this is their style, and this is their blind spots. And it's pretty good. It's not perfect, but I used it in class, and I had 2 students who were in the same lab, and the student A took it, and I was reading off the blind spots, and she was denying it, and her lab partner behind her was vigorously shaking her head, yes. And so it's kind of interesting. It's not perfect, but it makes you think about how different people react in teams. So this type of person would be respectful of others and provides order and structure. They lead reluctantly, though, right? And they expect others to follow the rules. And in an effort to satisfy everyone at the bottom, may have a hard time sticking up for themselves and being assertive. And we all know those kind of people in a team. Have little tolerance for ambiguity. Anyway, so there are 16 of these and different ways to work in a team. So others have thought about this, about how do you deal with yourself. I don't know if you're familiar in philosophy with their approach, which is a very interesting approach. So this was from Time magazine, and it's called the runaway trolley. I don't know if people are familiar with that from ethical debates in philosophy. But the philosophers have agreed to use the same case study and argue, how do you make ethical decisions? And in this case, there's a runaway trolley is heading down the tracks, and there's workmen on one side and a workman on the other. And you have to pull the switch to make it go left and kill the 5 workmen. If you leave it, it would kill the 1. So what do you do? And that's what they're talking about on the bottom there, divert the train or not. And many people will say, we need to kill a few to save many. Okay, that's your logic. And this continues, though. Now you have to actually physically touch the person and push that person because they're not quite on the tracks. And it actually gets more and more complicated, including there's a man on a bridge in that lower diagram who has a serious heart condition, who's about to die anyway. And if you throw him over the bridge, you can save the 5 workmen on the track. Do you do it? Now, and it gets more and more nuanced about how are you basing your decision. And finally, you can pull a lever, not actually touch the man. And do you do it or not? And they have paper after paper debating what is the ethical way to do things. My message from this is keep track of your decisions and why you made them, because they accumulate. And if you're not careful, you will contradict yourself at some point, and it happens. If each decision is somewhat isolated from earlier ethical decisions, you will find yourself in an awkward position. And what I do in class is they get all done with this, and lengthy debates about should you push the man, should you not? What if it's a baby on the track, an innocent baby versus 10 men on the other, right, who knew the risks of working on trolleys, I guess, at the time. Well, then, I always ask, do you donate to charity? Well, according to this logic, you should send all your charitable contributions to the place that will save the most lives. And we don't. And for example, in the United States, a lot of the students get Girl Scout cookies, right? Well, that's contradicting your logic you just told me about killing a few to save many. So you have to be very careful about these decisions. A philosopher, Kant, said, live your life as though your every act were to become a universal law, which is very good advice. Now, not everyone's a Kantian. Those who know philosophy, that's its own debate. But what does that mean? That means I'm making a decision now. If I had to make that decision every time that situation came up, would I be comfortable with that? And if others were faced with that situation and they had to make that decision, would I be comfortable with them making that decision? Aristotle said, we are what we repeatedly do. And that's how people observe our ethical or our ethos, is how we act. Ecological Society, remember, has a really interesting code of ethics for many years now, too. And some of these will make sense. This is now trying to codify how individuals should act, right? Offer advice only if qualified, cooperate with others, give full credit, not misrepresent results. But now look at the right-hand side. Will not discriminate based on gender, sexual orientation, differentiate facts, opinion, and hypotheses, not practice or condone harassment. Very, very interesting way to think about an ecological scientific society. Now, I Googled ICES Code of Ethics, and I was excited because I found this website, except it's about making cakes and sweets. It's the wrong ICES, but by the way, they have a really good code of ethics. Not only that, they have a conflict of interest policy, they have a grievance policy, they have a whistleblower policy. This is about sugary desserts. I'm not sure what the ethical issues are. And certainly a whistleblower, it wasn't whole cream, it was half and half, or skim milk, I'm not sure. But anyway, I thought I'd include this because I thought it was ICES, and I got excited, and then I was told, no, I read this and it wasn't. But so it's not just us, by the way. Many organizations are struggling with this. So yourself, remember that was the part, and then respecting others was the other part. So when you think about making a decision, the philosophers would tell you, is there goodwill? What are your intentions? Is there good reason? Why did you do something? Why did you say something? Why did you conclude something? Be reflective. These are not independent decisions. They accumulate. Admit to being wrong. U.S. politicians are notorious for their apologies. I laugh every time I hear one. I'm sorry you misunderstood my comment. That's not what was wrong. Your comment was wrong, right? apologize simply and clearly, and then be quiet, right? Otherwise, you just fuel this. Don't use convictions, right? I always did it this way. That's not a good reason to make a decision that involves ethics. And then always do what you consider is right. Plato had this idea that there's, and he used cats, he used trees. Somewhere up there, there's the perfect decision to be made. But we never actually observe it. We only observe imperfect versions of it here. So we can't just look it up. We have to muddle our way through. But the key is to give it careful thought. Find someone or several people whose judgment you trust. Ask them about it. And probably avoid email until you're sure what you're going to do. So it's your perception of yourself. It's how others, I should say, perceive you. Remember the past and understand your role, responsibilities, strengths, and weaknesses. For those who have done work where you really interact with the public and stuff, you sit at a table and we emphasize uncertainties and the attorneys emphasize certainties, right? You have to consider these type of things. Are there any? I know there's a couple of economists out there. Luckily, I can't see you with the bright lights, but if we try to put dollar values on everything, the environment will probably lose. I know that may not be a favorable statement, but it's very hard to do that. So understand your role, responsibilities, and weaknesses. Never make the science personal, but always make the team personal. What I recommend to students is when you go into a team science, now we have these projects, 4 PIs at 4 different universities. Sometimes people have never met each other 3 years into a 4-year project. And I really feel for the students who are trying to figure out, is what they're doing going to fit in well? What is the other group doing? We tend to ignore them that way, and it's just not fair, and it's not effective. And then they ask who should be a co-author, right? And we're not doing our job if you find yourself in that situation. I always tell them to, when they go into a big project meeting or something, observe first. Don't say anything. That's an example, is do as I say, not as I do. But don't do anything. And don't look at the speaker, look at the others. And you can learn a lot about the group dynamics by watching people's body language. People may not say things, but boy, they're not subtle sometimes in their body language. And you can learn the dynamics that way. And then participate, when you're doing it. And we really rely on email way too much. I discourage it. The classic was I sent an email down the hall to my colleague with 3 questions, and the answer was yes and no, right? And so I thought, why am I sending that? I'm going to get up and walk over there, right? So there's a trait in people. They only read the second half of emails. I don't understand that. So emails are not good for interactive conversation. So then you should check your emails more often on the bottom there. I fired you over 3 weeks ago. The other side of this, so that's about you. The other side of this is respecting others. And what I preach, I guess, is it's often not a conspiracy. Even though you may think that person is just, keeping me out of the loop and doing all these things, it's probably just benign neglect. And when we start attributing things to conspiracies over conspiracies, we really lose touch with the group dynamics, and it's not effective. Take credit for giving credit. If problems are repeatedly happening, it's probably you. Think about safe places, and that's taken on a different role in the US now, but back in the times of postmodern views of education theory, places where we call it, it's like Las Vegas. What's said there stays there, right? And that's very helpful. Always give credit where credit is due in safe places. One of the best versions of this I've seen is called the 5 R's, which I'm going to describe at the end here. And think of us, the way to think of it is that we're learners when we're working in a group, right? We're actually students learning about the group. it's the way to think about it is people, either colleagues or stakeholders, are confronted with difficult knowledge. And you're asking the learner, which is us, to recognize how implicated by the new knowledge. And it may challenge their psychological identity and how they understand the external world, particularly stakeholders. We all know fishermen will tell you there's more fish out there than ever, and we're telling them that it's at 2% of the historic spawning stock biomass, right? The learner then resists. So let me get to this. So this was a book written by my wife, and I was helped edit the book with her, and it really resonated with me that it deals with a lot of the issues that we deal with as scientists. And it's the 5 R's of working with people. Now, in her context, it's with difficult history. With us, it's more like dissident science knowledge. That is, it doesn't go along with what you have really been doing for the last 10 or 20 years, or you don't really believe it. There's questions about the methodology or the interpretation, as well as dealing with stakeholders. And so a way to view these contentious, somewhat tense meetings or interactions is to view that as people go through these 5 R's, and it's a good thing, not a bad thing. You want them to do this, right? Although you'll see on some of the steps, I know some of us get frustrated. So the first step in dealing with this is reception. They're there. They're sitting at the table. So they're willing to hear new information. It's called a willingness to hear, willingness to listen. So right away, that's a huge step, right? Even with a big team science group, everyone's there, they're enthusiastic, they're excited. Sometimes, either stakeholders more often, but colleagues, then show resistance. And Feldman called it the refusal to dialogue, the passion for ignorance. What you're being told, and this really applies to a lot of mostly stakeholder interactions, they resist it. It goes against what they perceive to be true and their experience, and it's psychological, and it upsets their internal ego. And so what happens? Well, they could just foreclose, it's called, and nothing gets done, and you want to avoid that. So the encouraging thing is maybe they're going to ask you to repeat it, and we've all experienced that in meetings. Can you tell me that again? And you explain it again. This is good, by the way. I know it sounds like an inefficient meeting, but that means that they've moved from resistance to repetition, revisiting the familiar and the unfamiliar. And we go through this at different rates, and unfortunately it's nonlinear, and you may jump from one R to any of the other R's. And so it's confusing because some people are moving towards reconsideration while others are still on repetition. But it's productive. This is okay. This is how people are going to, as Freud would say, shift their id to a new position, right? I guess Freud really wouldn't have said it that way, but it's Freudian anyway. Another step is reflection. So they resist. They ask you to repeat things. You do it a different way. They reflect on it. This is very good. It's called meaning making. They're working through this new information. Then they may jump back to resistance again, right? And you think, oh, this is a waste of time. We're going in circles. No, that's okay. They're still at the table. They have not left. And so you have to then work through it again. Finally, if they go resistance to reflection, to repetition, to reflection, to resistance, they might finally get to reconsideration, and opinions and conclusions are moved from the status quo. Now, I would venture to guess that most of the people in this room hadn't thought of these type of contentious meetings in this context. That people are just not listening, they refuse to acknowledge this, they do that. But if they're there, and you think about people going through this in different rates, stalled at different places, and you observe this, and I've begun to at meetings, more contentious ones, it's a little more obvious, particularly the resistance. But they actually can use this as a tool to keep the dialogue going. Because once the foreclosure happens and the dialogue stops, you have now distrust. And digging yourself out, either as a group or an individual, from distrust is extremely difficult. It's hysteresis. It's very easy to go down the distrust road, and it's very difficult just to back out of the distrust road. So this may be, not a way we normally think in a science conference about this stuff, but think about that in meetings next time. So observe the other people, look at their body language, not the speaker, and think about, are people going through this at different rates? And hopefully that may help a little bit. So what are the three things that get us in trouble? And then I'll end. Authorship. It seems so easy, but it's very difficult. And the reason is it's a simple rule. Remember those simple questions? How much water does the fish need? Authorship's easy. It's intellectual contribution. Now, operationalizing that is not so easy. Myself and Mary Fabrizio and Beth wrote a chapter in a book, Why is Something That Seems So Simple Often So Difficult? Peer review, part of authorship, if you think about it, is critical to public trust for us. And for those who are struggling with that, the one golden rule is don't put names down that you might have to take off later. That's a very operational rule, right? Seek advice, particularly the younger scientists, from someone who has experience with this. And because it's not, you can't just say, oh, never mind on the next draft, right? Be careful with that. Conflicts of interest, very difficult because it's perceptions. If it's a conflict of interest, get out. There's been many attempts to codify whether you have a conflict of interest. The National Science Foundation, our gold standard, United States for that. If you want to serve on a proposal review panel, a very codified set of questions. If you co-authored within 48 months, then you cannot. But there's one, I think it says, if you were on the same project for 36 months, you cannot. So somehow, one's 3 years, one's 4 years, and a very valiant effort. And it's great until you get to the final, bottom, last question. And it basically says, anything else? So it really hasn't accomplished much other than getting rid of the very obvious ones, right? Because now it's on you to say, what are possible conflicts of interest? And it's very difficult to do this. Be aware of how you look to others. It was just in the paper yesterday morning when I was at the airport in Baltimore. And there's objections to, I think, the new President Trump nominated someone who used to work for both EPA and, I think, the chemical industry. And there was objections for that. And I was thinking, boy, I've been funded by both industry and NGOs. I guess that means I have so little ethics that I can't be trusted for working anywhere, right? I mean, you have to be careful of that, right? We think industry, not in fisheries as much, but in others, it's not. You have to watch how you're perceived by others with who you work for and how you do it. In all the work I've ever done, consulting, private industry, government, NGOs, no one has ever even suggested that I change my conclusions to match their agenda, ever. Maybe because I always agree with them, I don't know, but that's, it's difficult. So this is, the Science March on Washington was an example. Our students went, and I reminded them, great, you should go, but think about how that may look, right? Are you an advocate? Should you be an advocate? Does it conflict with being a scientist? Even on a different topic, right? So I'm a fisheries scientist who doesn't collect data. Should I go in front of the school board and talk about evolution? Well, when I walk in as a professor, I get a certain amount of credibility or worse yet, should they collect data is probably a better one, where I'm not qualified to discuss any more than any other citizen. But yet you have to be careful because you're wearing this scientist hat. How do you present yourself, right? Do you get undue credibility? An excellent paper on advocacy by environmental scientists, what, whether, why, and how, I would recommend it. I'm old school. I guess I'm past mid-career by now. We were taught not to get involved, that would diminish our ability to appear to be objective. Now, I think times have changed, and now you probably do get involved. And that's a fundamental change, but with it comes perceptions. They make the argument that your obligations as a citizen, I almost said trump, overwhelm your obligations as a scientist. I know nothing about the subject, but I'm happy to give you my expert opinion. You'd be surprised how often it's perceived that way, to do that. Should you do that or not? You need to decide for yourself, but don't think that it is not noted over time, just like your decisions are, by others. It is. And you need to, if you're aware of it and you still decide it's the right thing to do, you should do it. But don't go in with eyes wide open. And then finally, and this group knows that maybe 15 years ago we weren't adept, but socializing is a way to have trust. And we know that, and there's a whole series of pictures here. Probably what's more important are the two quotes. No, actually on the top right is Shinichi Ito, who's in the audience, was visiting me at Mardi Gras. I suspect he remembers Mardi Gras. I'm not sure he remembers what we talked about, but Plato said, you can discover more about a person in an hour of play than in a year of conversation. And science groups are good at this now. They weren't in the past so much. And then the best way to always end a talk is quoting Einstein. You can't go wrong with that. He said, if A equals success, then the formula is A equals X plus Y plus Z, where X is work, Y is play, and Z is keep your mouth shut. So this is probably a little different than the usual talk. Hopefully you found it interesting. I hope you found it useful. My goal really was to get you to think about how as an individual you interact with other individuals that make up these teams and that deal with stakeholders, and the role of trust in both team science and stakeholder engagement, and how to earn trust and keep trust. And I will close with a comment that some of us are probably too deep in our ways, but we really need to educate as educators and train the next generation to deal with these type of interactions. And I don't think we're doing a very good job at that, at least to my limited knowledge. And hopefully we can do something, not just all technical, but interacting with people and trust and ethics and all those topics that I tried to cover rather quickly. So with that, I'll stop.